Hello, this video is about solving equations. It's an intro to solving equations. An equation is a statement that says that two algebraic expressions are equal. So an example of that, x plus 2 is equal to 7. A solution, which is what we're going to be looking for, is values that will make an equation true. So whenever you're trying to find a solution for an equation, you should be asking yourself the question, when is this equation true? Or in other words, specifically, when is x plus 2 equal to 7? So the answer for us will be when x is equal to 5. You'll always be able to check your solutions by plugging whatever you're saying that your solution is back into your original equation. If it creates a true statement, then you know you have a solution. So if you're saying that x plus 5 is the solution, plug 5 in right here. 5 plus 2 is equal to 7. And so that confirms that that is our solution. So now, in order to solve our equations, we will be using what I call opposite operations. They're operations that undo what the other one does. Addition and subtraction are opposite operations. Multiplication and division are also opposite operations. They undo what the other one does. So if my goal is to have my variable on one side of the equation by itself, I need to undo what's being done to it. So if I have x plus 2 equal to 7, I need to undo the addition of 2 to the x. So the first thing we need to do is recognize that we have a left side and right side of our equation. When I look at x plus 2 equal to 7, my equation is split up by the equal sign. It's to the left side of my equal sign and to the right side of my equal sign that I have the left and right side of my equations. Now, in order to keep my equivalency, whatever I do to the left side, I need to do to the right side, or whatever I do to the right side, I need to also do to the left side. Once again, that will keep my equivalency. So if I see that I'm adding 2 to my x and I want to remove the addition of 2, then what I would need to do is subtract 2 to cancel out the addition of 2. Once again, using my opposite operations. Now, if I subtract 2 on the left side of my equation, then I need to also subtract 2 on the right side to keep that equivalency. So positive 2 and negative 2 will cancel on the left, and then on the right, 7 minus 2 is 5, and that's how I have my solution. So simple one step solving equations. If I go down here looking at x plus 3 equal to 10, I'm adding 3 to x, so I need to subtract 3 from both sides. Doing that, my solution will give me x equal to 7. The 3 cancels on the left, 10 minus 3, 7 on the right. This one, y minus 20 equal to 30. So I will add 20 to both sides because I want to cancel out the negative 20. Adding 20 to both sides cancels out the 20, leaves me with y on the left. 30 plus 20 is 50 on the right. Here, I have 5a equal to 13. Whenever I see a number right up against a variable, that implies multiplication. So that's 5 times a equal to 13. So in order to remove the multiplication of 5, I need to divide 5 from both sides. 5 over 5 cancels, gives me 1. So I have 1a equal to 13 over 5. I do not have to convert that to a decimal unless directions say specifically for me to do so. But I do have to reduce if possible. 13 over 5 does not reduce, so I can leave it as 13 over 5 for my final answer. Then for this last one, m divided by 9, equal to 11. Multiply both sides by 9. 9 over 9 cancels, leaving me with just m. 11 times 9 gives me 99. Okay, so here, negative x equal to 7. My goal is to get x by itself. I don't want to solve for negative x, I just want to solve for x. So I can either multiply both sides by negative 1, divide both sides by negative 1, or just take the negative to the other side of the equation, and that'll be x equal to negative 7. If I have negative x equal to negative 7, if I take that negative to the other side, don't forget negative to a negative turns positive, so that'll be x equal to positive 7. Okay. Looking at these last 3 examples, before we go there, don't forget that 1x and x are the same thing. 1y and y are the same as well. So in other words, when you don't see anything sitting in front of your variable, they assume you know that there is a 1 sitting in front of that variable. So when I go down to this first equation to solve, negative 8 plus 3x minus 2x equal to 12 minus 9, I can combine my like terms on both sides of my equation. 3x minus 2x is 1x. So once again, I'm not putting that 1 in front of x. The most simplified way of representing 1x is just x. So that's negative 8 plus x, and then 12 minus 9 is 3 on the right side of my equation. Now I can add 8 to both sides because I have a negative 8 here. I need to cancel out that negative 8 with a positive 8. Adding 8 to both sides gives me x equal to 11 for my solution. For the next one, the first thing I would do is distribute into the parentheses. I need to remove the parentheses so I can have access to the y that's inside of those parentheses. So 2 times y is 2. 2 times 1 is 2 as well. So that gives me negative 5 equal to 2y plus 2 minus y. Combine my like terms. I have 2y minus 1y, which is just 1y. So that'll leave me with negative 5 equal to y plus 2. Now, once again, my goal is to get y by itself. So what's being done to y is the addition of 2. So I'm going to subtract 2 from both sides of the equation. 2's cancel on the right, leave me with just y. Negative 5 and negative 2 will give me negative 7. Last one for this video, 2x plus 3x equal to 54 minus 9. Once again, combine your like terms on both sides of the equation. So we have we have 2x plus 3x, which is 5x. On the right, 54 minus 9, which is 45. Now I have 5x equal to 45. Divide both sides by 5 in order to remove the multiplication of the 5 to the x. 5 over 5 will cancel, leaving me with just x. 45 divided by 5 will leave me with 9. So that's an introduction to solving equations.